Good morning. Good morning, everyone. So, we are waiting for 2 more minutes and then we will start the session. Good morning, Suryavanshi. Good morning, Meghashri. Good morning, Surya Pratap. Okay, so we will wait for 1 more minute and then we will start the session. Till then, whatever materials that we have mentioned in the poster for today's session, please collect all those materials at one place so that during the activity time, you have all the materials with you. Good morning, Amit. Great. So now we can start the today's YouTube live. So again, good morning, everyone. Welcome you all to Tan90 YouTube live on Ohm's Unplugged. I am Rupesh, and I welcome you to this YouTube live. So today we will learn and not only learn, but we will apply the concept of Ohm. So before starting that, what is the statement of Ohm's law, where all it is applicable, where it is not applicable, what is the application of Ohm's law, or who is Ohm. So before going to that, there are some things that we should know, and the because of any law, any science law, whatever we are doing today or whatever we are able to use today, whatever facilities that we are getting today, whatever innovation that we are getting today, all of because of some or the other scientific laws. So Ohm's law is also one of the biggest, what we say, one of the biggest invention, you can say, or you can say it is one of the most important and most fundamental law of physics, especially in the world of electricity. So whatever applications or electronics items we are using it today, the main reason for this is because of the Ohm's law. So what is the Ohm's law? Before getting into that, we should first know about who discovered, or you can say who published this, who was the main father of this Ohm's law. So his name was George Simon Ohm, ये एक जर्मन मैथमेटिशियन थे एंड फिजिक्स, ही वॉज अ मैथमेटिशियन फिजिक्स फ्रॉम जर्मनी. इन 1789 ही टुक बर्थ इन दैट प्लेस. इनकी हिस्ट्री के बारे में अगर बात करें तो हिज फादर वाज अ जनरेशनल लॉक स्मिथ और यू कैन से ब्लैक स्मिथ, जो लोहे का काम करते हैं. स्पेशली दे वेर ट्रेन टू मेक अ गुड लॉक्स फॉर द किंग्स. तो ये भी इनके फादर चाहते थे कि इनके जो दो बेटे हैं, जॉर्ज साइमन ओम, और एक उनके एक और बेटे का नाम है जो मैं बोल रहा हूँ. सो ही वांट बोथ द सन टू participate, or both the son to learn that blacksmith and continue this generational locksmithing process or locksmithing work. But one of his teacher, or you can say the one of the professor, he wrote a letter to his father that both of your son are very good in mathematics and they have a very good understanding or very good analytical and logical skills they have. So he requested that to his father that please do not involve them in the generational locksmith work, but educate them in the field of science, in the field of maths. He asked him to send them to colleges so that they can learn and understand the application of mathematics and science. Although George Simon Ohm, he didn't, he went to a college, but due to lack of funding, due to lack of resources from his parents' sides, he was not able to continue his education in the field of science. So very little knowledge about the field of science, but he was so much curious. He already loved mathematics, so he started a teaching job in the German. So he joined as a maths professor, a maths teacher in a school, and but still he didn't like his job because he wanted to learn more about science. But unfortunately, he had to work for his living. Still, during his leisure time, he used to write one book on geometry. So very few of us know that George Simon Ohm, who has discovered or who make this Ohm's law, he was also a very great mathematician, and he wrote a textbook on geometry. So this is how we know that okay, even if in your hard times, when you are when you don't have resources, when you don't like your job, or when you don't like the things going on, but if you are consistent on your effort, you can definitely be recognized today or tomorrow. One of the basic facts about the Ohm's law is that in 1827, the Ohm's law was first published by George Simon Ohm. But many of us, means not us, but many of those scientists, they didn't recognize it. They said that the logic what Ohm is saying, we will talk about this logic, that what logic he was saying in the Ohm's law, what logic that George Simon Ohm was saying, it was not practical, and it was not so much kind of revolutionary. So still through very long time, in a very long time, it was not been recognized. मतलब ओम्स लॉ आया, ओम्स लॉ पब्लिश हुआ, वो बस एक नॉर्मल पेपर बन के रह गया था, कोई उसको कुछ कदर ही उसकी नहीं थी, या इसका इतना बड़ा एप्लीकेशन हो सकता है किसी को एहसास नहीं था. देन हिज फ्रेंड, हिज नेम वॉज Charles Wheatstone. So we all know about some concept. We have heard this name, Wheatstone Bridge. We have learned this in grade 10 and grade 11. So the person behind that Wheatstone concept was Charles Wheatstone. So by his PR, by his effort, he he put more effort on showcasing, on promoting the Ohm's law made by George Simon Ohm, and finally in 1842, George Simon Ohm's law was recognized by the Royal Society, the society where the group of scientists were there. So this is the time period in which that Ohm's law got recognized. So from this also we get this learning that if your work is good, and if you know that someone has worked very hard, and his or her work should be recognized, then you should also take effort as a social responsibility to make those things published, or make those things recognized by the to the people. So because of that, Charles Wheatstone only, the Ohm's law, the George Simon Ohm got recognized, and finally we are using Ohm's law in all over our during our life or in all over our appliances. So this is a small history about George Simon Ohm. You can also read about it. It's very inspirational, and it shows about the hard work of a person and the time which he got recognized. Now coming to the importance of Ohm's law. So, what we can say that because of this Ohm's law only, we are able to see each other, and in behind of each and every electrical and electronics item, Ohm's law is there. This is the part of the application. Talking about the academic part, Ohm's law is very important as it is comes in grade 10. So in grade 10, in every board exams from Ohm's law, 3 to 5 marks questions they ask. In 11th also, when someone takes science, Ohm's law is there. In the graduation also, if someone do BSc or a BTech, even in the competitive examination, the questions are asked from the Ohm's law, because Ohm's law is a very fundamental law of physics. So it's very important to understand its basics. So today, the today's session will be more of a inquiry based session, and it will be more of the how to understand Ohm's law by doing the practical, how to learn Ohm's law or how to teach Ohm's law by doing some practical or some activity, so that a student or ourselves as a teacher can able to explain the Ohm's law through a activity. So this is the main agenda of this. We will not discuss each and everything about Ohm's law, but we will discuss about the activities that we can use to understand or to explain Ohm's law. So for this, before jumping to the activity, I want to ask you few questions. So let's play a rapid fire round. So I will ask you one question and you have to answer that in your chat box. Okay, so are you ready to play a small quiz before jumping to the activity? It's very exciting quiz, and I think all of you know the answer of these questions which I will be going to ask. So are you ready? If you are ready, you can type Y in the chat box. If you are ready for the quiz, you can type Y in the chat box. Yes, sir. Good. I got response from Avinav. Yes, I got response from Surya. Great. So I think I have a green signal to start the quiz. Okay. So my first question: what do you understand by the term voltage? You can just give a random answer in the chat box. Okay, no need to give any bookish definition. What do you understand by the term voltage? When you heard voltage, what do you think? What is voltage? You can write your response in the chat box. I am watching all your responses. I will be reading all your responses. So that's why I have opened my laptop. I will see. So you have to share your thought. What do you understand by the word voltage? What is voltage? All of you quickly write your answer in the chat box so that I can understand that what do you think about the word voltage. You can write any random answer. No bookish answer is required. Okay. Because before going to the Ohm's law, we should first understand the basic term. Voltage क्या होता है? ये आपको chat box में लिखना है. Yes, I got a response from Abhinav. Voltage is the force that push electric charge to move through a conductor. Very good. Mohammad Arif, voltage is the electrical pressure. Very good. Great. Anyone else? Any one word answer? What is voltage? Great. So the responses from which we got is electrical potential difference. Nice, Surya. Great. Electric charges. Okay. Anyone else? Great. So by the term voltage, we all understand that voltage is the cause, or you can say voltage is the pressure. According to Arif, voltage is the force that we apply on current. Voltage is the cause which allows the current to flow. So we can simply say voltage is the cause and current is the effect for whatever it is. If you are turning on a TV, if you are turning on a bulb, lighting a bulb, if you are turning on a fan. So voltage is the cause and current is the effect. Yes, voltage is a push force. Okay, what is the unit of voltage and current? Very simple question. Very childish question, but it is not childish. Voltage, unit of voltage and unit of current. You can type in the chat box. This is the question number 2 of the rapid fire round of the quiz. What is the unit of voltage and current? Volt and ampere. Volt is the unit of voltage and ampere is the unit of current. Very good, Surya. Okay. What about resistance? What is resistance? What do you mean by the word resistance? Anyone? Suryavanshi, anyone? What do you understand by the word resistance? I am just not talking about in the terms of electricity chapter or in the terms of science. You can just give your answer. Oh, Ankit gave a proper definition, difference between the electrical potential between 2 points. Yes, Suryavanshi. Abhinav gave a good answer. Resistance is the opposition that a material or object offers to flow of electric in opposition. Good. Arif, I asked what do you understand by the word resistance? Very simple question I have asked. Achha, do we mean that if I say resistance, it many people say that resistance stop the flow of current in a conductor. Is it right? Is this explanation right for the resistance? Resistance stop the flow of current in a conductor. Is it correct? Or if we say that resistor restricts the flow of current in a conductor, is this statement correct? Okay, I will give you one more statement for the resistance. Resistance controls the flow of current in a circuit. So I have told you 3 statements for the explanation of resistance. Resistance stops the flow of the current in a circuit. Resistance restricts the flow of current in a circuit. Resistance controls the flow of current in a circuit. इन तीनों में से कौन सा सही है, कौन सा गलत है? क्या तीनों सही है, क्या तीनों गलत है? क्या स्टेटमेंट 2 सही है, स्टेटमेंट 3 गलत है? क्या आपको लगता है? If you want, I can repeat my question. Resistance stops the flow of current, or resistance restricts the flow of current, or resistance controls the flow of current. Anyone who wants to answer this? Think. So my three statement was resistance stop the flow of current, or resistance restricts the flow of current, और रेजिस्टेंस कंट्रोल द फ्लो ऑफ करंट। इन तीनों में से कौन सही होगा? या तीनों सही है या कोई दो सही है? सी स्टेटमेंट वन रेजिस्टेंस स्टॉप द फ्लो ऑफ करंट इज कंप्लीटली इनकरेक्ट। वो बिल्कुल नहीं होगा। पहला वाला रेजिस्टेंस स्टॉप द फ्लो ऑफ करंट, नो। इफ रेजिस्टेंस स्टॉप द फ्लो ऑफ करंट देन व्हाई वी आर यूजिंग इट इन द इलेक्ट्रॉनिक डिवाइस? वो बंद ही कर देगा। एंड एट द एंड वी हैव टू use that device, no? If we are using a electric kettle, we need hot water. If we are using a bulb, then we need light from it. If we are using fan, then we need air from it. तो चलना तो चाहिए. So for making it work, we should not stop the flow of current. The purpose of resistor was to that our system, or what we say, our load means the fan, the bulb, the TV, the mobile, it should not get burned by the excessive flow of voltage, because you only told that voltage is the pressure, voltage is the push force. So voltage doesn't understand anything कि भाई the TV or the mobile is of low voltage power, TV is of high voltage power, fridge is of low voltage power. उसको पता नहीं है, वो सीधे वोल्टेज भेज देगा। तो उससे क्या होगा? दैट इक्विपमेंट विल बी बर्न, इट विल गेट डैमेज। So to restrict the flow of current, to regulate the flow of current, to control the flow of current, resistor is used. ये concept clear है? This should not be a misconception. In many, I've seen when I was a teacher, student used to write the definition of resistor. Resistance stop the flow of current. Stop नहीं करता है, वो उसको restrict कर देता है। If 20 volt is going, it will give only 18 volt. Whatever voltage is required by the appliances, by the load to work, वो उतना देता है, उससे ज़्यादा नहीं देता है। And this is how it is saving that equipment to getting burned or damaged. This is clear? This definition is clear, or this understanding about resistance is clear? So option 2 and option 3, the statement 2 3 somehow was correct. Option 1 was definitely a big no. Okay, so what is the unit of resistance? Unit of resistance? Very good, Megashri. Ohm. ठीक. And this ohm, so this resistance ohm, as I told you that in 1842, after so many times, the Ohm's law published in 1827. Then in 1842, from the Royal Society, the Royal Group of Society, they have recognized George Simonot, and they have given the unit ohm as its recognition, as a tribute. So वहाँ से ये ohm word आया. Now coming to the activity. अच्छा, activity से पहले एक और question, my last question. ठीक है, before jumping to the activity, last question. After that I will not ask you any question, we will do the activity. So we just discussed about voltage, current and resistivity. Is there any relation between voltage, current and resistance? Is there any relation? क्या कुछ relation भी है, या ये तीनों अलग अलग चीज़ है पूरा, या कुछ relation होगा? You just have to say yes or no. मतलब you don't have to explain it. Do you think that there is a relation between voltage, current and resistor? Good, Harshit. बहुत बड़ा relationship है सर. Yes, good. So yes, relationship तो है. There is a relationship between voltage, current, resistance, and this triggered in the mind of George Simonot. So जो भी उसका relation है, we will understand it and we will discuss it after doing the activity. So now coming to the part of activity, I will show you the equipments which you require to build the activity. I have already made it to save your time. If you don't have it, you can collect it afterwards, after this session, and you can make it. It is very easy. So we all know how to make a simple circuit. In simple circuit, we are using only three equipments max to max. First is the power source, which is a battery. Then we use a, in simple circuit, then what we use? We use a load जो power को consume करेगा. So here we have a torch bulb or a bulb, or you can use LED bulb. And what we use? This wires. These wires are the conductive path. And at the end, in simple circuit, what we use? A switch, which makes or breaks the circuit, which allows the current to flow whenever we want. So in the place of switch, now we are using a DC regulator. This is called a DC regulator. You can see it is a DC regulator. What does it regulate? It regulates voltage. It is a DC regulator. So the construction of this circuit is same like a simple circuit. Only in place of switch we have replaced it with a voltage regulator, and that too DC voltage regulator. This you can easily find in your nutcut lab, and you can easily find it in the local shop also. So this DC regulator is used in the emergency lamp, in some DC equipments, like I told, lamps. The lamp is there. Then we have a solar lamp, solar powered lamp. So there also you will find this kind of DC regulator. Okay. If you closely see this DC regulator, you can see that there are resistors, few resistors attached. 1, 2, 3, 4, 5. Total 5 resistors are attached in this DC regulator. And how are you connecting this DC regulator? You can see here that there are 2 holes present in it. There are 2 holes present here, hole 1 and hole 2. So you have to fix the wire. If you want to put a switch or put a regulator in the black wire of the battery, you can use DC regulator here. So in between this black wire, the negative wire, I have placed the DC regulator. You can also put the DC regulator on the red wire. So it's up to you which wire do you choose to put a DC regulator. Okay? It's not that you can put it here only, you can put here also, because it is a circuit. I suggest that you should always put a switch or a DC regulator in between the negative wire. Okay? In between the negative wire. But you can also put it in the red wire, means the positive wire. It will work like same. Okay? So it's my habit to put switch in the black wire, which we call negative wire, the negative terminal. So what I have done, this is a circuit, power source, load, connecting medium, and I have choose one negative wire, and in that I have placed one DC regulator. So this DC regulator right now it is acting like a switch. So it breaks the flow of current in the circuit. It breaks the flow of current in the circuit. That's why this bulb is not glowing. आपको बल्ब दिख रहा है क्या जलते हुए? नहीं. Why? Because this switch, this DC regulator is now at 0, and it made this circuit as a open circuit, and hence this bulb is not glowing. Now, once you made this circuit, it's very easy circuit. I will share the circuit diagram also. It's not there is no rocket science in making this kind of circuit. What I will do, I will check that now whether my circuit is working or not, whether all the connections that we have done is correct or not. So now I am just turning on, or what we say, I will just rotate this knob of the voltage regulator and see that whether my bulb is glowing or not. One नहीं हुआ, 2, 3, अच्छा So let me show you like this. It will be good if you solder the wires which you have placed so that this wire will not grow. I have just fixed it using my hand, so that's why there is some loose, because of the loose connection the bulb was not glowing. So let me turn off it again and then I will use it. So what I am doing, I am just fixing the black wire, which we call negative wire, which came out from the DC regulator back to its. Yes, Arif, you told that we have a multiple resistors fixed here, so it's right, we have multiple resistor, but we will discuss this in more detail after this activity. If you have materials with you, you can also make this kind of circuit. It is very easy, just we have to fix a battery, a bulb, and in between any of the wire you can fix a DC regulator. So this is the DC regulator. You just have to fix this. No need to fear, Arif. The bulb will glow. कहाँ जाएगा? Because of the loose connection, sometimes it doesn't. If you solder it, then it will become more durable. So till we are making the circuit, can anyone guess that who was the inspiration for George Simon Ohm for discovering this Ohm's law? Anyone? Do you know that who was the inspiration? Like we all have some inspiration, no? We have role model, or we have some ideas that help us to think out of the box. After which law George Simon Ohm got this clarity that there is a relationship between voltage, current and resistance. You have 5 minutes. You can think that who was the inspiration and after which activity or after which discovery George Simon got inspired to make this Ohm's law. Great, I think it will be working now. We have to be gentle with these circuits. Great. Are you able to see the bulb, glowing bulb? You can type yes in the chat box if you see the bulb glowing. Great. One, two. Actually the two wires are touching each other, that's why sometimes it is glowing. Okay. So now let's see that whether this bulb is glowing more or not. So now I am reducing the voltage in the bulb. Understand it, what I am doing, trying to do. So now in my voltage regulator there are total 7 steps, you can say, or 7 knobs. So like I am turning on to point 1. Okay, you can see a very little glow, or the bulb glows very little. Okay, then I put it to point 2, just like our voltage regulator, which we use in our home for controlling the speed of the fan. Same regulator, a DC regulator, I am using to control the flow of current in my bulb. Now see, is there any difference? If you feel any difference, you can write yes. If you feel that the bulb is glowing brighter, you can type yes in the chat box. Great. So now what we have seen, that whenever you can just make this and play whole day, that how this is becoming brighter and brighter with the help of DC regulator. And you can also change the bulb. So right now I am using a torch bulb, the filament bulb. You can use it with LED bulb, you can use it with 1.2 volt bulb, see what happens, and just check that how this is behaving. Is it really glowing this bulb brighter, or it is just the normal flow or normal circuit that we have made? So you can check it. So basically what we are doing, we are just putting the flow of voltage, or we are just allowing the voltage to pass through this circuit and go to the bulb. But what new we are doing, how we are doing, that is important. So it is a complete closed circuit. As we know, simple circuit, very closed circuit is there. Right now it is open, but as we turn it on, what we are doing, we are just putting the potential difference, we are just increasing the potential difference, and as a result we are just increasing the voltage, and as a result the flow of current in the bulb gets increased and the bulb glows brighter. And when we go from point 5 in the reverse direction, 5 4 3 2 1, so the bulb becomes dimmer. Let me explain you again. So what we have done, we have connected the circuit and we were turning the voltage regulator knob from 1 to 7. So in 1 the bulb was glowing very little, in 2 it became more brighter, in 3 it became more, in 4 more, in 5 more, and in 6 7 it was glowing with its full potential. And when we reducing it from 5 4 3 2 1, the bulb which was glowing very bright, it is now becoming dimmer and dimmer and dimmer. So this shows a logic that whenever you are increasing the voltage, the current gets increased. It means that current across a conductor, so this is a conductor, bulb is a conductor, good conductor of electricity. So current across a conductor is directly proportional to the voltage applied across its ends. So this is the conductor, these are the ends where we have fixed the wire. So the current across a conductor is directly proportional to the voltage applied across its end. Here voltage is coming from the battery, and this voltage is increasing the current. This voltage, because of this voltage we can see the bulb glowing, and the intensity of the bulb which it glows from dimmer to brighter, it totally depends on how much voltage you have applied to this conductor. So it is directly proportional. We will not say that it is equal. So 5 volt voltage, so 5 volt current. No, this is not the correct way to understand Ohm's law. It is directly proportional to the current. Means what I am saying, or what Ohm's law is trying to say, if you increase the voltage, then the current will also increase. So if you want to make the bulb more brighter, or if you want the fan to rotate at full speed. If you want the mixer to rotate at full speed and chop the food, then you have to increase the voltage applied across it. And to increase the voltage, we are using this DC regulator, which is actually a voltage regulator. This, have you understood? Is this clear? If it is clear, you can write yes. If it is not clear, you can write that I want to understand. You can repeat the concept, sir. This is what Ohm's law was saying, that it was a very logical thing also. मतलब ऐसा नहीं था कि बहुत ये था, शायद इसीलिए इनको पहले रिकग्नाइज नहीं किया गया, लेकिन जब इसको धीरे धीरे और समझा गया तब मालूम चला कि नहीं, इन्होंने बहुत बड़ी बात कही कि इट वॉज अ वेरी लॉजिक, वेरी कॉमन सेंस that if you want to increase the flow of current in a conductor, then you have to increase the voltage. So the current flowing in a conductor is directly proportional to the voltage applied across its ends. In some law, if you read NCERT book, it is written that current flowing in a conductor is directly proportional to the potential difference applied across the conductor. So what do you think? The voltage and the potential difference are same, or both of them are different? What do you feel about this? I will repeat my statement, that in many books it is said that the current, many books it said about the Ohm's law that current across a conductor is directly proportional to the voltage applied across the ends of the conductor. And in some statement you will find that current across a conductor is directly proportional to the potential difference applied across the conductor. क्या ये दोनों बात सेम है या ये डिफरेंस है? In short, do the word voltage and the potential difference are same thing, or it is different? Because this is again a very confusing thing which comes to a student. As a student, I was also very confused कि potential difference किसी स्टेटमेंट में लिखता है potential difference, किसी स्टेटमेंट में लिखता है voltage, तो क्या ये दोनों अलग है या सेम? What do you feel? You can write in the chat box. क्या दोनों बात सेम है? Yes, they are same. So we can understand this by one analogy. Imagine you are in a hill station. ठीक है, very good imagination. We are in a hill station and river is flowing. River is flowing, and then suddenly there is a waterfall here. So it is on the mountain. River is flowing on the mountain on a very high stage, and it flows from the waterfall and meets to the river. So water flowing from here, getting down to the river, and then it is flowing. So imagine this. This is the analogy to understand what is the potential difference and what. So the water which was flowing on the top, this is the electric potential. This is the potential. Imagine this is the potential of the water. So we can say that this is the electric potential, the river flowing on the top before coming down. So this is the electric potential. Electric potential means charge, what we can say, per unit charge. Per unit charge. So it was flowing here, this. And then when it goes down with full potential, so now it is, we say that it was a work done per unit charge, means from top to bottom, from the top of the river flowing through the bottom. So this was the potential. This was the potential difference. Here was some potential, and when it came down to the river, it meets the river. Here is some other potential. So this potential and this potential difference, while following it down, we can understand, or we can think like that this is the potential difference. So as we know that the water, or we can say that the current, and here the water, and we are relating it with the current. So current flows from higher potential, or what we say, voltage. Voltage flows from higher potential to lower potential. So this is the same thing, that when the voltage was here, the voltage was normal, then it flows, and then it becomes, so this difference, this is the potential difference. But potential difference of what? The voltage only. So that's why the voltage and the potential difference are the word same. Yes, if you explore it more, then you will find that okay, it's the work done per unit charge. This is called a potential difference. Means from point A, from point A to point from point A to point B. What is the difference from point A to point B? This is the potential difference. So this you can understand by more exploring it. But the same voltage and potential difference are the both of the words are same. Now in the Ohm's law, it is also state that current is directly proportional to the voltage applied. That we understand that current across a conductor is directly proportional to the voltage applied across the ends of the conductor, and inversely proportional to the resistance applied to the conductor. So here you can see the resistance. Here you can see the resistance. So this resistance is inversely proportional to the current. ठीक है, we should not get confused. वोल्टेज बढ़ेगा तो करंट भी बढ़ेगा, बट अगर रेजिस्टेंस बढ़ गया तो करंट घट जाएगा. If we increase the voltage, the current will also increase because they are directly proportional to each other. But if we increase the resistance, then current will decrease. ठीक है? So that's why the formula says V is equal to IR. So that R is a constant of proportionality. Then we call it as a resistor in the terms of word of physics. But V was directly proportional to I. But the current is inversely proportional to the resistance. Current will never increase if you increase the resistance. So here in our project, in our circuit, what was happening? Actually, this voltage regulator, it is at point 0, it is off. At point 1, for example, here we have 4 resistors. So this resistor is of 220 ohm, but let's assume that this resistor is of 1 ohm. मान लेते हैं 1 ohm है, ठीक है? So how many resistor? 4 resistor. That means 4 ohm. How you can say 4 ohm? If you see it closely, what kind of connection is it connected? If you see it closely, you can see the 4 resistor. What do you think? Which type of connection are they connected? Are they connected in series? Are all the 4 resistors are connected in series? Or are all the voltage resistors are connected in parallel? What do you think? I am talking about this voltage regulator. You can see that there are 4 resistors. So what do you think? These resistors are connected in series with each other, or they are connected in parallel with each other? Yes, they are connected in series with each other. So in series connection, for resistance, the resistance gets added. So now when the resistance, when the regulator was at 0, it was turned off, it was a completely open circuit. When we put it at 1, then what happened? The bulb was glowing very dimmer. Then what does that mean? Think little bit, then I will answer. When I put this voltage regulator at point 1, the bulb was glowing very dimmer. Then what does that mean? What does that mean? Again I am repeating my question. When I have turned this voltage regulator and put it at 1 from 0, the bulb was glowing very little, very dimmer. Then what does that mean? According to Ohm's law, what does that mean? It means that the resistance was increased. At point 1, the resistance was increased. So there was 4 resistance, no? So all the resistance were added, and as a result only little bulb was glowing, only little amount of current was flowing through the bulb, and the bulb was glowing. Now when I turn it to 0.2, then what it happened? The resistance which was added, the 4 resistance were added, now only 3 resistance are added. So 3, for example, 3 ohm, it is not 1 ohm, it is not 3 ohm, but let's say that now 3 ohm resistance is applied. So the lesser resistance is applied. As a result, in Ohm's law, what they have said, that if resistance decreases, current increases. So here resistance decreases, the current gets increased, the bulb glows little bit more brighter. Then we put it on 0.3 or 0.4. Then from 4 resistance, means 4 ohm, now only 1 ohm was getting applied. So as a result, the more amount of current was flowing from the battery to the bulb, means more amount of voltage was flowing, and as a result, the more amount of current was getting to the bulb, and the bulb was became more brighter. So this voltage regulator, what it actually do, when you put it from 0 to 5, it has 4 to 5 resistors in it. According to that, according to the use, or according to the resistance value, it start adding, or it start decreasing the amount of resistance which it is getting, which it is applying. Now one more question about this is that I have told that there are 4 resistance of 1 ohm, 1 ohm, 1 ohm, which is actually 220 ohm. But why are we using the same value of resistance? What do you think? हम लोग सेम क्यों यूज करते हैं? Why can't we use 1 ohm, then 2 ohm, then 3 ohm, then 4 ohm? ऐसे हम लोग क्यों नहीं यूज करते हैं? सेम क्यों रखा हमने? So the reason why we have put it the same value is because to get the sequential output. मतलब ऐसा नहीं हो कि at 1 the bulb is not glowing and at 2 the bulb suddenly glows very bright, then at 3 it is getting very little dimmer, and at 4. तो वो अगर if we use different value of resistance, then this problem will come. So that's why whether it is a DC regulator or whether it is a AC regulator, we always use the same value of resistance so that sequential currents are allowed to go to the bulb and make it brighter. मतलब थोड़ा सा से little dim, then more dim, more brighter, then more brighter, then more brighter. तो ये एक sequential होना चाहिए, नहीं तो in the fan, in our fan also, at 1 there is no speed and at 2 it is full speed. So this is not required. This is not a correct way to use any appliance. So that's why same value of resistance is there. Only according to our need, the resistance value are getting decreased to increase the value of current. So that's why our scientists, they have made this kind of regulator. I hope you have understood about Ohm's law. What does Ohm's law states? Now we can conclude that. Yes, Arif, what question you have? Arif, you can type your question here. How it might be a confusion for you, but if you see this voltage regulator, you can just open it and see it. Then you will be able to find out whether this regulator are connected in series or parallel. According to me, it is connected in series, but you can just open this and you can check and you can take a picture of it, and you can say, then it will be a good point to discuss that whether all these resistors are in the voltage regulator are whether connected in series or parallel. Okay? So this was about the Ohm's law. As I told you that we will not discuss more about the Ohm's law, but we will discuss about what activity can be used to explain Ohm's law. So this is according to the Ohm's law, it states that the current across a conductor is directly proportional to the voltage applied across the conductor, and it is inversely proportional to the resistance. If you increase the value of voltage, the current definitely it will be increased. And if you increase the value of resistance, then current definitely it will get decreased. Sure, Arif, you can take that picture and send it to us. Then we can discuss that whether it is in series or parallel. And if we connect resistance in parallel, then what effect it will happen, and if we get resistance in series, then what connect will happen. Now my one question for you all is that you have to make a proper fan which works on the DC regulator using the same circuit. So we have using the DC regulator to control the flow of voltage of the bulb. You can use the fan. So to make a fan, what material you have to use, what design you have to use, and if you have any other facts or very exciting facts about Ohm's law which we all don't know, please share it in the comment box, or you can share it with us in the WhatsApp box. So I hope you have understand about Ohm's law, and this was more about how to understand Ohm's law by doing the practical. In our next session, I will come with some other law which can be explained using any other activities. It will be of electricity topic only. Thank you for the joining. And if you like this session, you can share your thoughts, and don't just listen to my thoughts. You can also explore your concepts, explore the research on more Ohm's law. And thanks to George Simon Ohm that we got this Ohm's law, and we have using it in all our electronic appliances. So thank you, team. We will meet in our next YouTube live. Thank you for joining.